All right, in this video, we're going to take a look at solving applications of using systems of equations, so how this stuff is used in the real world. So setting up many applied systems of equations problems boils down to a very simple concept that a unit rate times an amount will equal a total amount, usually a total amount of money paid or something like that. So for instance, we have a unit rate of $2 per gallon of gas times an amount of gallons of gas, which in this case would be 5, would equal a total amount of money paid for the gas, which is 10, because $2 per gallon times 5 gallons will give us $10 to spend that we need to spend for the gas. So example 3a, how many milliliters of a solution containing 10% pure hydrochloric acid must be mixed with a solution containing 15% hydrochloric acid to produce 30 milliliters of a solution that is 11% hydrochloric acid. It's kind of weird how the hydrochloric acid is just all lined up here. But so we're taking a solution. We don't know how many milliliters we should have of each, but the first solution is 10% hydrochloric acid. The second solution is 15% hydrochloric acid, and we want a total of 30 milliliters, that is 11%. So I guess we can think of it as we're mixing in 10% hydrochloric acid to soften the percentage of this solution's 15% hydrochloric acid. So let's say X represents the number of milliliters of the 10% hydrochloric acid, and then we'll let Y equals the number of milliliters of the 15% hydrochloric acid. Well, first of all, in terms of actual volume of liquid, we have X number of milliliters of the 10% acid solution plus Y number of milliliters of the 15% acid solution is going to equal 30 milliliters of just liquid. So our first equation, and it doesn't matter what order we write these equations, but our first equation, we can look at it in terms of just volume of liquid, not worried about what's in the liquid or what it's made of, just how big of a container we're going to need to hold all this liquid. So we're going to need at least a 30 milliliter container. The next equation, we can look at it in terms of the amount of acid in each of those liquids. So our X liquid has 10% acid solution, so 10% of our number of milliliters of our first solution is going to be pure hydrochloric acid, so only 10% of it though. Then we have 15% of the next solution is hydrochloric acid, so 15% of Y, or 0.15 times Y, equals, we want the solution, our mixture, to be 11% hydrochloric acid, and since we have 30 milliliters of that solution, 30 times 0.11 will give us our volume of total hydrochloric acid. So here's how our system of equations looks. Our left-hand side will have 1 and 1, and then 0.1 or 0.10, and then 0.15. And then our right-hand side, we have 30, and then 30 times 0.11 is 3.3. Now, the good news is most matrix calculators, you don't need to actually do this calculation separately. You could just type it in as 30 times 0.11, and it'll store what the answer of 3.3 is without you having to do the calculation already. All right, so let's enter this into Desmos and see what we get. So we're going to do a new matrix. It's going to be 2 rows, 2 columns, and it's a 1, a 1, 0.1, and a 0.15. Whoop, way off. All right. And then matrix B was 2 by 1. And we had 30, and we had 3.3. Now, just to illustrate that we don't need to do the calculation separately, we can actually type it in as 30 times 0.11. It'll keep it as 30 times 0.11, and if you want to verify that it actually is 3.3, you can just type in the name, and there you see the 3.3. But we want to do A inverse, the inverse of A, times matrix B, and we get 24 and 6. So doing that for X and for Y, we get 24 and 6. Now, I'm not looking for just 24 and 6. I'm looking for an interpretation that actually answers the question. we said that X is the number of milliliters of the 10% solution and Y is the number of milliliters of this 15% solution. So for your final answer, you need to interpret your results for X and for Y based on what you said X and Y represented. So this sentence right here is what I'm looking for the final answer. So mixing 24 milliliters of the 10% solution with 6 milliliters of the 15% acid solution will give us our required mixture. So we'll have a total of 30 milliliters here, and then if we took 10% of 24 and 15% of 6 and added them together, we'd get 3.3, which is 11% of 30. All right, part B, we have a coffee shop that wants to sell 8-pound bags of a coffee blend for $28.64. They're going to do this by blending coffee that costs $2.25 a pound with coffee that costs $4 a pound. So how much of each coffee should they use in the blend? So we want to make this blend. We want to sell it for $28.64. Maybe it rounds up to $30 with taxes, so it's nice even number. I don't know. I don't own a coffee shop, but I do enjoy coffee. So let's say X represents the number of pounds of the cheaper coffee, which will be the $2.25 per pound coffee. And then we'll have Y equals the number of pounds of the more expensive coffee. So since we're looking at how much of each type they should use, we're looking at X and Y representing our solutions should represent the number of pounds of each type of coffee. So just like with the last one, our first equation represented just volume of liquid. Here, our first equation is going to represent just volume or weight, rather, of coffee. So we have X plus Y equals 8. So the number of pounds of the cheap coffee plus the number of pounds of the more expensive coffee should be 8 pounds total for the bag. And then the next one, we'll look at the price. So we had $2.25 a pound times X number of pounds for the cheap coffee, and then $4 a pound times Y number of pounds for the more expensive coffee. And we want to add those together and have the result be $28.64. So our matrix equation looks like this. We got a 1 in the first row, and a 2.25 and a 4 in the second row. And then our matrix B on the right-hand side is 8 in the first row and 28.64 in the second. So I'm going to clear this out, and new matrix A, 2 by 2. We got 1 and 1, 2 and a quarter and 4. And then matrix B, going to be 2 by 1. We have 8 and $28.64. And then if we do A inverse times B, we get 1.92 and 6.08. So X is 1.92 and Y is 6.08. And what that means in terms of the problem is if they want to make this 8-pound blend of coffee and sell it for $28.64, they're going to need to use 1.92 pounds of the cheaper coffee, the $2.25 coffee, and then 6.08 pounds of the more expensive coffee. If we do 1.92 times 2.25 and then add 6.08 times 4 to that, we will get $28.64. And 1.92 plus 6.08 does equal 8 total pounds. All right, so that about does it for this video. Thank you for watching. I'll